Oh yeah, for like the last page.
Okay, did you guys get the tests?
Yeah.
All right. The tests are here on the table next to Nick. And then I'm going to keep track of the time again. So when you get done with your test, bring it up and I will rate your time on yours. And then, Menominee, can you raise your hand when you're done and I will wave to you that I got you so that I know who finished their test. Okay? Get her done. On your mark, get set. Okay, we have to have a word of encouragement for Madeline. All right, you can use your book. We are going to have a group test. It's multiple choice. You can use Desmos.
It's a math test, that's why.
Oh, okay. All right, get her done.
It's math.
Are you done with your test? Okay. Can you write what time it is on your test when you finish it, and then when I get it in the mail, I'll be able to get the times?
You're really quiet, Kevin.
What was that?
Turn it up a little bit.
I said, can you, when you get done with your test, write what time it is so that I know how long it took you to do the test? Can you hear me okay now?
Yeah, no, it's good. He turned it up for us.
Okay. Thank you. If you guys in Menominee are all done with your test, you can bring them over to the office so that she can fax them to me. Okay? Thank you.
You only wanted the time for people now, right?
I'm writing down yours on the back of your sheets.
It was much easier to slam.
Okay, you can take your break, unless you're still working on your test.
John, when you would I just said you had to say like most movies will be after like Jordan everything else watched
So, did anybody get their deer on Saturday or Sunday?
No, I went back and make sure I had everything and then
If you guys are ready, you can take your test and go over it across the. I think it's open. Just a second. Let me check to make sure. Yeah, you can take your test over there and do it. You can start it whenever you want to. I'm just saying, since you four are all sitting there, you can go whenever you want to. You what?
I'm online shopping, so
Shopping?
going on, Kevin.
I'm sure there is. Isn't there always a sale going on? Kohl's or Clothes?
Especially if it's Kohl's, yeah. Always Kohl's cash. Every time.
Okay. Menominee, you guys have one copy. Jess, you are their scratcher again. You can go to across the hall there and get your copy done. I've got them here. When the guys come back, you can take it. Here's yours. Go for it.
This is so neat. It all looks familiar.
You weren't here when we did it last time?
It doesn't
Oh, well, explain it to her when you get over there, okay? You guys have to leave, though, because Menominee has to be able to talk to Jessica, so you have to go to that room across the hall like we did last time. Okay? Well, when he gets here, I'll tell him to get over there. And if you want to sit down, madam, I've got a chair for you.
I'm gonna grab the coin.
Oh, good idea. Good idea. Talk, Menominee, so that I can see if I've got to adjust the volume.
Hello.
Do you want it a little louder, Jess?
Sure.
Okay. Talk again.
Hello.
There you go. Sounds good.
Okay.
They went over there, Nick.
First one, what do we think? For the B.
I had B.
Yeah, I had B too.
Alright.
Do we see the scratch off?
I'm sorry, I didn't hear you.
Do we see the scratch off? Or
Oh,
once-
just wait. I've got a... Yeah, I screwed up. There you go. Sorry about that.
Thank you. I put C for number 2. I put D.
I put A.
What did you put?
I put C, but quadratic you need 4 points, so it could very well be. I don't think it's linear because if you look at the rate of change between 4 and 6, it's not 10.
Exponential then.
What'd you put, Jess?
I think I put C.
Okay, we'll go with the first anyway.
C then?
Yeah.
No.
Oh.
So that must be A.
Quadratic A.
Yeah.
How would you prove it?
Carefully.
Remember, you start with the second difference. So to figure the second difference, you have to figure the first difference. Right?
So you
Yeah.
have to be B.
Or the slope, at least. So
Oh, it is.
if you put down a column on there, you call it D1.
Did you get that marker back?
You got to twist it. So D1, there's none in the first spot, right? So put a dash in the first spot. From 2 to 0 is 2, and from 20 to 10 is 10. So the slope there is change in y over change in x.
5.
5, right? Okay, for the next one down,
10.
10. And for the next one down,
15.
now, if it was exponential, it would be 5, 10, 20, right? 5, 10, 20, because it would double each time. So then go to D2. So how much was the change? Oh, you got dashes on the first two, right? First two.
What?
First one and the second one both. How much is the change from 10 to 5?
Five.
How much
Yeah,
is
five
the
again.
change from? Yeah. So the second difference is. So that's, yep. So that's why it's quadratic, not exponential. Okay.
Number 3, I put A because it's still slope is steepest.
A.
That's what I put too.
Alright.
Yeah.
Yahtzee.
Okay, so 4.
4. I had D as well. I put D.
That'd be.
That's what I had as well.
What's the consensus?
Is that your test or is that your notes that you're looking at there?
Me?
Oh.
Yeah.
No, it's the notes, but I wrote down the answers.
Oh, okay. Because I was just making sure that you got them so that I get the facts from the office. That's all I cared about.
Five.
So for
Um,
5, I
that's
put
D.
C.
Yeah, they're the same, so
Yeah.
we'll never meet.
Yeah.
C then?
Yeah.
I have only one wrong. Fine, yeah.
Number 6.
I had D.
I put D as well.
I put D too.
No, let's see. 7. I had B, but I completely guessed.
I didn't know what 7 was.
I put C, but
I think I just guessed B too because I didn't know how to do it. So which one do we want to do?
Take out your graphing calculator or my graphing calculator. Go to Polysimul 2.
I've never used a graphing calculator.
That's okay. I'll show you.
it's number 9.
Click apps. Apps. No, that's math. It's okay.
Oh, yeah, sorry.
Go
Number 9.
Polysimul 2.
I don't have that on my
Okay.
computer, so I couldn't do that.
Well, then you have to solve it with simultaneous. Oops, this is not the right one. We want simultaneous equation solver. Okay, your two equations. You have the weak a pharmacist needs to mix 3-gram liter solution in a 12-gram solution to make 10 liters of a 6-gram solution. So this is the kind where you set up the tic-tac-toe. You have the weak plus the strong adds up to 10. The weak is worth 3, the strong is worth 12, and the 10 is worth 6. Multiply across, what do you get? 3W, 12S, 60. So your two equations are next. Your two equations are 1. So put in a 1 there. Nope, on your computer, on your calculator. 1, enter. 1, enter. 10, enter. 3, enter. 12, enter. 60, enter. Solve. Yep, that one. 20 and 10 which is
C.
C.
Totally guessed. Totally guessed.
So C.
Yeah.
Yep. Is that what he said? C?
Yeah.
Look at that.
Said C, one of them said B.
All right. Number 8.
It's 100% B.
Yeah.
Yeah.
That's right. Number 9. I put.
That's what I put as well.
I can see.
C?
Yeah.
No.
So,
Trying to figure out which one I did. I put B. I think. You wanna go for that one?
Yeah.
sure.
Okay. I wasn't right either.
Which one are you doing?
9.
Oh, we didn't get that right?
D.
We go with D.
Okay.
So I think that's what I put.
Oh.
Uh-oh.
Okay.
Yeah, no, you can't do that because you can.
What's the power of 2x squared over x cubed when you get done?
You have
X to
two.
the... Yeah, it's 2 over x, correct?
Yeah, you'd have to simplify that down and become 2 over x.
Which gives you a negative power.
Yep.
Oh.
Oh, yeah. Duh. X. Okay. That's
10.
I hate math. Math in that respect is just stupid. I'm sorry. Like, it's a positive, it just happens to be in a fraction. I'm sorry. 10. I put D.
I put A.
Oh, no, I'm sorry. I'm looking at the.
I put A as well.
When we get to calculus,
I put A on that. I wrote down D.
one of the problems that we have is being able to find the differential of a fraction like that. And so writing it as a negative exponent helps us not have to do the difference equation.
So A on that one?
Yeah.
I just forgot to mark that down on my sheet, so I'm sorry.
Ooh.
What?
What? I don't think it's C.
I guessed A, so I don't.
Why did you say it's not C?
I don't. Just give me a second.
Go C.
Send it.
C.
And then negative 2 times negative 2 positive 4?
Yeah.
Or maybe you thought you were adding?
I don't know. I've taken math twice for a reason. 11. I put D, I think.
That's what I had.
Yeah, I had D as well.
Okay. 12.
Should have bold-faced not. Maybe people wouldn't have.
12, I put B.
Yeah, I put B as well.
They are inverses?
Yeah.
Okay.
Yep.
You tried to trick me, Kevin.
I did not. I just said they are inverses.
It was in your voice. I could hear it.
Oh, okay.
Okay, so 13.
I put C for 13.
Yeah, I put C as well.
Agreed?
Yep, that's right.
Yep. 14.
I got that one wrong.
I put D for 14.
Yeah. I put D too.
What's the reasoning behind that one? Because I had B. I'm just curious.
On number
Because
14?
Yeah.
you have to keep what's in the parentheses together. Because, like, if you were to try and solve it normally, you would square the in the parentheses. So, therefore, if you were to go the other way, you'd keep them together and you put the x and the negative 3 in a square root.
Okay.
And then continue with the inverse. I'm pretty sure it's just.
So it could either be C or D.
Yeah, it's
Your
C or
line.
D, and I figured.
Well, it's a negative because it wants it to be less than, but it
Yeah.
says less than 3.
I forgot about that.
I put, which one do you want to put? 'Cause I put D.
Kevin, can you give us some direction on this, please?
Okay, so start with make your function with the arrows thing. So start with X over on the left hand side of your paper. Straight down, X.
X is greater than 3.
Okay, then what's the first thing you did? Subtracted 3. So do an arrow, just like I do, up and over to X minus 3. You don't remember how that goes?
I'm so confused. I'm sorry. I'm not your best student.
So you start here.
Okay.
The first thing you do is subtract 3.
And then you square it.
And then you square it. And you get X minus 3 squared. And then you add 1. Correct? You get X minus 3 squared plus 1. Now start at the other end and go backwards.
So we do minus
Minus
1.
1. You can shut up. Don't even look at me with your face.
So you get X
It would be B.
Then you do
minus 1, right? Then you square root that. And then you
That I hate.
subtract or add 1.
Was it, so 1 was in this guy?
Oh no, you add.
Yes.
Or X minus 1
Ha!
plus 3.
Yeah, plus 3.
E, I meant to scratch off 2A and not 1A because we had that.
Oh,
right
yeah,
there.
because you had that one right?
Yeah.
Okay.
So,
I was thinking of negative, not positive.
okay, I was gonna say you would make
A then.
A.
Yeah.
I'm all shiny, guys.
And then 15.
Did you figure out your mistakes, ladies?
Yes, and we will be emailing you for the retake.
So what do you guys have for 15?
We put D.
Yeah.
Is your computer plugged in there?
Yeah.
I mean, it's charging? Okay.
Yeah.
16. I had D again.
Oh my god, wait, can I show you?
What was the question?
Oh, yeah.
Is it
It's A.
No, it's not a.
Rate is changing at a. What's the question? What's the.
No, what?
Well, when I calculated the rate of change.
Is it falling at a constant speed?
Yeah, it's falling at a constant speed. If you run the numbers, you got to do the math on it. It's A.
Hold on.
The numbers are different in the left column. The spacing is different in the left column.
The
spacing.
spacing
Oh,
is
is
different. Correct.
Okay,
So it's A.
A.
Yeah.
Oh, I like that
What?
Ooh.
But it's like $2.98 for every one of them.
Well, because when I calculated, it wasn't constant for every pair of rows in the table.
But the difference in the X between the first one and the second one is 10. Between the second and the third one is 8. Between the third one and the fourth one is 7, 6, 4, 3,
Try D.
7.
That
You
was
see
a.
how your X's are not the same. So you have to find the slope. That's what you have to look at, is what the slope is in each one of those cases.
If we get you back, well, me personally, if I get you back the retake ASAP, will you put the retake score in before that number? Because
We're
I-
gonna go with D as our next option.
You really
D.
D is the dog.
You could take it next hour, because I'll be in my office.
Last one.
I have to present that.
How about at noon?
Yeah, my bio class.
D.
I go home and eat and then I work right
Let's
after.
see.
Consensus says C is
Tomorrow?
What?
I work right after this.
D. Yeah.
Before this class? Tomorrow? I know it is, because
That's
it's
the
written.
door I like. Thank you.
Hey, Mr. Hulkey, did someone say we can do retakes?
Yeah, but it has to be where I can supervise you, so I don't know how that's going to work for you guys in Menominee. Like maybe if you stayed in there after class, let me see what days there's somebody in here.
They're in
We got a
today.
Tuesday or a Thursday.
I mean, I
Because there's English Comp 1 in here.
Yeah, I could talk to Jennifer and see if she would supervise you, because you could just sit in the back row there and take it in the back of the room.
They do it tomorrow?
Yeah, that's what I'm saying.
Yeah.
I know what credit card.
Did you guys hand yours in? Do I have them all now?
I mean, if he's going to let us do a retake one.
Gotta see them.
Who's?
You shut one group in.
Oh, I still am waiting for them.
Did you go
Like,
through
can
Harry
you reach it
Vision?
right after this class?
Did you go?
Yeah.
You mean,
Because like he adds in this one.
oh, that's
Yeah, I'll be down in
just
my
put
office.
it on
I don't know.
Okay.
So probably up to
Yes, do
8.
we have to go down to
Yeah, because I want to make sure that the person whose name is on the test is the person.
Oh,
Oh, I'm rich beyond my wildest dreams. Somebody left me a tip. I feel like one of the waitresses. Or, excuse me, servers.
That's cool. It's a passing grade. That's all we have to do.
Are we?
We're waiting for the other group to get here.
the 70.
That's all we're doing.
All right. That's
Sitting and waiting.
With that 4-row?
Without adding on.
C plus.
Yeah, C plus.
I'm good with that. We did well enough on that. Well, let's do a B minus.
How many points is the that little extra thing that would do worth, Kevin?
You mean what Jessica was scratching off?
Yep.
Okay, so your test is worth 75% of your grade. Your group test is worth 25% of your grade. Oh, okay. So, when you say how much is it worth, that's my response. Does that explain it to you, how much it's worth?
Kinda. Like,
You feel dumb. Raise your hand if you feel like Maddie. She says, I feel dumb. You know, and the thing is, what do you expect? This isn't like easy stuff. This is a hard class. So, do you think that in the scoring of the test, I take that into account? Yes, I do. Okay, do I expect you to get perfect papers? No, I don't, because there's just so much stuff that we learn. So it is a tough thing, but it's a continuous learning opportunity. Okay, don't think you aren't very smart because you didn't get a perfect paper on the test. This stuff is hard. Anything you want me to go over with you on the test? Can I have the test, please? Do you guys have, is that my test or is that the review there?
No, this is a test.
There
We
you go.
wrote on it though.
I know I wanted to see the things that people wrote on.
Would number 2 be exponential and
Okay, let's look at number 2 because that's an important consideration. If you graph number 2, let's go to Desmos here. So let's graph number 2. I'm going to put in a table, and I'm going to put in the points. 0 is 10. 20 is 2. Oops. 4 is 40, and 6 is 70. Okay, so if we change our values so that our graph goes from 0 to 10 and from 0 to, let's say, 100, just so that we can see all our dots. Okay, so on here, if we connect the dots, it looks like it could be quadratic or it could be exponential, right? I mean, just by looking at it. If it is exponential, exponential, let's add a, oops, I can't use the word exponential. Exponent. Nope, can't do that either. Let's just call it Z just for the fun of it. Okay, so remember that you can't do one point all by itself. So in this one, you take the change, if it's exponential, it's the change in y divided by the change in, it's the new y value divided by the old y value. So we get 20 divided by 10. Oops. Divided by 10. Okay? Oh, which is 2, right? Down here, you get 40 divided by 20, which is also 2, right? And in this case, you get 70 divided by 40. What do you get when you take 70 divided by 40? Well, you don't get 2. Everybody agree with that? So if this was exponential, this point would have been 80. 6 would have been worth 80. So it would have been, if it was exponential, it would have been higher. It would have scooped up faster. How do we find out if it's quadratic? Well, we need another, I'm going to call this column W. Remember that for that, the first thing you have to do is find the average rate of change. I wonder if I can, no, I can't call it average rate of change. So we take 20 minus 10, which is 10. Yeah. Where did I put them? No, that's okay. Well, I look at it as in class. But what you can do is work in this room over here, and then when I'm done, okay, so what do you get for the, you know what, I should be doing this on paper. Let's take out paper and let's do it there. Zero, 2, 4, 6, 10, 20, 40, 70. New divided by old. Well, you can't do it there. New divided by old is 2. New divided by old is 2. New divided by old. So we'd take 70 divided by 40. We get 1.75. AROC is what's necessary to find out if it's quadratic. Okay, so the AROC here would be 20 minus 10 divided by 2 minus 0, which is 10 divided by 2, which is 5. Next one down, 40 minus 20 divided by 4 minus 2 is 10 I'm sorry, 20 divided by 2, which is 10. 70 minus 40 divided by 6 minus 4 is 30 divided by 2, which is 15. Second AROC. You can't have one here, see, and you can't have one there. So the first one you can have is 10 minus 5 divided by 4 minus 6. 10 minus 5 is 5. 4 minus 6 is, I'm sorry, I got that backwards. 4 minus 2. 4 minus 2 is 2. And then the last one, 15 minus 10 divided by 6 minus 4 is also 5 divided by 2. So the second differences are the same in a quadratic. This number would have had to have been 80 for it to be an exponential. Next. Any other questions on the test? Page 185. Imagine a roller coaster traveling along a section of track drawn as follows. The coaster starts out at time 0. And reaches point B at 2 seconds. And it takes an additional 3 seconds to get to point C. On the axis below, sketch the height. Okay? Well, everybody agrees that the height at the beginning, A, is the same as the height at the end, C. The height at point B compared to A and C, what do you think? It looks pretty much the same, doesn't it? What happened between A and B? It went uphill and then back downhill, right? So in that spot there, it went up a little bit and it came back down. What happened after it left here until it got back down to C? It did a loop, but what happened to its height? We don't care about its direction. We only care about its height. It went up in the air, and then it came back down again, right? Okay? Would you agree that when it went up in the air, it spent a lot of time at the top before it came back down again? How do you know your graph can't have a loop in it? And a graph of a function passes the vertical line test, right? So it's not going to go backwards in time. Let's graph this function as given on the next page. So take out your device and we'll graph it. T to the 6th, 14t squared. Oh, where'd it go? Here it is. Ooh. Oops. And we're supposed to graph it from 0 to 5 seconds. And it's going to go from 0 up to about 60 meters. I can't remember how high it goes. 70 meters. Nope, a little bit more than 70. Let's make it 80 meters. So when you graph it, is that what you get for the graph of the roller coaster? And if you notice, it, as I said, it quickly got up to that top, to that peak, and then it came back down again. Part A says, set the viewing window so that you can see important features of the graph over the first 5 seconds. One of the things that you don't know is, what is an important feature? So when you graph it, Eric, that, it looks like your horizontal axis is wrong. Try 0 to 5, because we only care about the first 5 seconds. Maybe you're, there you go. And then go up to 80 meters. Anybody else need help, or has everybody got it graphed? So how do you know which are important features? If you click on your graph, it will tell you what the important features are, because it puts dots where the important features are. So one of the things that you're going to want to know is, what is an important feature of a graph? Okay, so we sketched it, and it went up, and down. And when we put dots in, we got this point, this point, this point, and this point. Was there another one on there? I didn't notice. No, it doesn't. There's not one at the end there. So what is true about those points? Why are they important? Anybody know? Yeah.
I could totally be wrong, but it's kind of like the vertex.
Kind of like the vertices, yeah. They call them turning points, or they call them maxima and minima. That takes care of most of them, but there's one more important point that's graphed on there. And what is that? This point right here. So you're going to graph zeros, those are important, and you're going to graph turning points, which these three are turning points. But a turning point that's at the top is a maximum, and a turning point that's at the bottom is a minimum. So those are the ones that they mean are the important features. When, part B, when is the coaster at its highest point? Part B, what does it say? 3.78 seconds, and how high is it? 79 meters. Okay, part C. When is it making its fastest descent? Bracket 3.78, comma 5, right? Because we only graph for the first 5 seconds. We're going to see what happens after 5 seconds. How did you know this is the steepest section of descent? Because it's sloping down the fastest for part C. How did you know? Because it's sloping down the fastest. Then it says, examine the behavior outside that. Well, let's go to, instead of 0 to 5, let's go from negative 10 to positive 10. And to do that, we're going to have to, I guess our graph isn't that bad. But what happens before 0? Comes down really quickly. What happens after 5 seconds? Goes up really quickly, right? Could this function make a good model for the height of the roller coaster after 5 seconds? Well, you've ridden enough roller coasters. What has to be true? The farther you get into the roller coaster ride, the lower it gets, right? Actually, usually it starts out with a really high hill, really towards the beginning, and then every hill after that is a little bit lower because it loses momentum as you go along. Part 3, another roller coaster ride, the back and forth roller coaster ride. Let's graph that one on number 3. 0.3 t squared minus 8t squared, or t cubed minus 8t squared plus 45.5 t. A negative means you're to the left. A positive means you're to the right. It says use a graphing calculator or app to plot the graph. Set the viewing window so that you can see all the importance over the first 20 seconds. Okay, so I'm going to start here at the middle. According to that graph, what's the first thing I have to do? Go to the it's positive. Which way do I go if it's positive? What does it say? A negative value means goes to the left, so positive means I'm going to go right. How long do I go right? For about 8 seconds, somewhere in there, right? 8.23 seconds. Then what do I do? At 8.23 seconds, since it's negative, I go to the left, correct? Okay, I go to the left. How much time do I spend going to the left? Oh, I'm sorry. I did that wrong. Start here at the middle. I go to the left until I get to 3.54 seconds. Then I stop going left and I start going right. And I get back to the middle at 8.223 seconds. Then I go to the left until I get to about 14 seconds. Then I stop going left and I start going right. And I get back to 0 at about 18 seconds. You with me? Part B, when does the ride change direction? 3.54 seconds and 14.223 seconds. So these are the spots where it changes direction. These are the spots where it's at the beginning point. These are the spots when it's left of that beginning point. These are the spots when it's right. These are the spots when it's right of that turning point. These are the spots when it's left of that middle point. Page. 187. And when we go for this one outside of that interval, we'll see the same thing, -10 to +30. You can see that it can't be a roller coaster because before time 0, you just keep coming from the left-hand side, and just after 18 seconds, you keep going to the right-hand side. Page 188.
Do we have class on Wednesday?
Yes, we do. It says the electrical power required to run a coffee shop varies throughout the day. So let's sketch a graph of how much power the coffee shop uses. Since it says a day, let's start with 0. And let's go all the way up to 24, because a typical day will be 24 hours, right? And let's say this is the maximum, and we don't know a lot about how much power it is, but let's just say that the maximum is going to be up there someplace. At midnight, in a coffee shop, is a coffee shop using a lot of power?
Yeah.
Is it using 0 power?
No.
No, because you're always got the refrigerators or stuff running, okay? Would you agree that over here it's going to be using the same amount of power because it's a typical day? It will end with the same amount of power that it began at? What time would you guys say is the most power being used at a coffee shop? What?
9 a.m.
9 a.m.? Does anybody have, like, late in the evening? Because don't people go to coffee shops in the evening to, like, study and stuff like that? You don't know. Not me.
I don't study.
Janae.
Our coffee shop is usually busy when like class gets out, like around like 3, I'd say. Our lobby is like really busy with college students.
How about compared to 9 a.m.?
Yeah, not like during the school year, it's pretty dead.
Because if you aren't in class, you're probably in
The coffee shop.
no bed
Oh.
at 9 a.m.
Oh yeah.
Yeah. And then, so to me, I think Janae may be onto something there, maximizing at some point like that, and then going back down. Now, we will find out. Pierre would like to model the electrical power demand of his restaurant as a function of time. He sketches the graph of the function, and here's the graph that he made. And notice, he didn't do the whole thing. He only did from 11 a.m. to, what would 20 be, 8 p.m.?
8 o'clock, yeah.
8 p.m. That's all he did. So we will start there tomorrow with the graph on 13.B. Let's sketch that graph just so that we can get started tomorrow on it. I can hear you.
See you later.
See you guys.
So what are we going to be doing on Wednesday?
Yeah,
Just
if
a
I
normal class day?
take Wednesday off, I got to count it as a vacation day, and I like to use my vacation days for fishing, not for sitting around the house.
I'm not going to be there.
While my wife is cleaning up for company, seems like a real advantage to me. Hey, you poor things. You just worry way too much. Don't worry. You have to get an A? Okay, well, get all of your get all of your My Math labs done before you retake the test.
Yeah, I called you tonight because yesterday.
So that might be part of the problem that you're having.
Like biology.
Because you need to get those done first.
Watch me get like when I'm in the test, I see it and I don't know.
So an idea for that is one course